use computer. Okay, so happy Monday, happy February 1st. We're gonna start with section 4.1 and we're gonna go over system of linear equations. So the first video is gonna be over graphing, solving by graphing. And here we have two different methods of solving algebraically, which is substitution and additional method. That's gonna be second video. Okay, and the third one is gonna be application, which means word problems. So I'm gonna start with solve by graphing. And you're gonna do that later on when you do applications, when you do optimization problem, when you have to find maximum or minimum. So now how you solve by graphing. So pretty much system of linear equation means you have two linear equations and you're trying to find the common solution, which means what they have in common, where they cross each other. So you're going to graph the two lines you have given, and wherever they cross, that's the solution of the system. So first I'm going to graph these two linear equations. So I'm going to start with number 1. And in order to graph it, I need 2 points. So the easier way to do that is you're going to make that little T table, it's called, but also you can, T table is because it's like a T, letter T. And you have X, number for X, number, you're going to find number for Y. So what you're doing, you're going to pick number for X. Usually 0 and 1 is good numbers. They're small numbers and it's easy to calculate. So I'm going to pick 0. So when I replace X with 0 in the first equation, so when doing the first equation, I'm going to replace X with 0. And then I'm going to find what is Y. So I'm going to have Y equals 7 times 0 plus 10. 7 times 0 is 0, so my answer for Y is going to be 10. And then you do the same with X is equal 1. So I'm going to plug it in. So I have Y equals 7 times 1 plus 10. 7 times 1 is 7 plus 10 is 17. So my Y is going to be 17. So now these are the 2 points I need to graph, 0, 10, 1, and 17. And that's going to be the graph of the first equation. And then after that, I need to graph the second equation the same way. So I'm going to pick 2 numbers for X. So this is my second equation. And I'm going to do the T table in this side. So I'm going to pick X. Again, I'm going to pick 0 and 1. So when X is 0, what I have Y equals negative 4 times 0 minus 1 is negative 1. And then I'm going to replace X with 1. So it's going to be Y equals negative 4 times 1 minus 1 is going to be negative 5. Okay, so these are the 2 points I need to graph to get the graph of the second equation. Okay, everybody good so far?
Yes, ma'am.
Any
Yes,
questions? No? Okay. So I'm going to graph those 2 straight lines. And wherever they cross each other, that's where is the solution of the system. So I'm going to go try to do like a little, if you have a graphing paper, probably is better. I'm going to do it like this. I'll have all the way to 17. Let's see. Okay, so we're going to start with the blue line. The first one. The first equation is 0, 10. You know what? 0, 10. Let's do that. I'm going to move this just all the way to 10, 17 actually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and okay, 17 is going to be a little up. 10, and then I have 0, 10, 1, 17. So this is how the graph is going to look like, something like that. And then the other graph, the red one, is going to be 0, -1, and 1 and -5. So where they cross each other, somewhere here, right? And that's where the solution is. Okay? So where is the solution? You just have to get the coordinates of this point. It's about -2, 2, 3, 4, 5, 6, 7, and 7, right? About -2. So when x is -2, okay, so now you have to graph very precise to see. And let me show you something. I'm going to show online graphing calculator you can use to check your work. So the graphing calculator, I'm going to show you Desmos. It's online. And what I'm going to show, it's really easy to use. So I'm going to put the first equation, y equals 7x plus 10 was the first one, right? And that's the first line. And then the second one was, what was the second one? 7x plus 10, -4x minus 1. Like that. And where they cross each other, can you see? -2 and
3.
3. Everybody see that? Okay, my graph is a little off, and if you want, you can just click there, and it's going to give you the coordinates. Everybody see that?
Yes.
Okay, so you can use this graphing calculator, but I just want you to understand, to go through the process. The process is, oh, sorry, what was the solution? -1 and 3. Okay, so this is not -2. -1. My graph is a little off, that's why. So it's going to be -1. It's going to cross a little down here because the line, hold on, the blue line is going to be, 17 is going to be a little up. Okay, I'm going to try to fix this. So this line is red. The red line is good. And then the blue line is going to cross here. Okay, so it's going to look something like this if you graph it more precise. So this is -1 and 3. So you can check your work with the Desmos, with the graphing calculator. Okay, so that's how you solve it. Any questions? Okay, let's go. No? Okay, let's go ahead and do one more. So I'm going to do like number 3 or number 4 because the equation looks different. See, these equations are in standard form. So I'm going to...
Actually, I do have a question. So besides using like graphing it on an actual like graph like you just did, is there any way to solve for that point of -1 and 3 besides graphing it out?
Yes, yes. That's the two methods we're going to go over, additional and substitutional.
Okay.
Yes, yes. We're gonna solve it by actual methods, by calculating the solution. Yes, yes, we're gonna do that. Okay, but this is graphing method because later on we're gonna need to graph. We're gonna be able. We need to graph. System of equations. Okay, so we're gonna. This is what you're doing a graphing right now, and later on we're gonna solve it with actual solution, like different algebraic method, calculating the solution, okay? Okay, so let's do one more with graphing. So the next number 3 and number 4, pick one.
Number 4.
Number 4, let's do 4. So again, we're gonna graph it now. In this case, the equation looks different. It's not y equals, it's standard form, 3x plus 3y equals 18, okay? So the way to solve this, to graph it, it's easy if you use x-intercept and y-intercept. And you're still gonna get 2 points. But here we're gonna pick 0 for x and also 0 for y. These are the x-intercept and the y-intercept, if you remember from last time. So when I pick x is 0, I'm doing the first one. I'm gonna plug it in my first equation. So it's gonna be 3 times 0 is gonna be a 0, right? And I have 3y equals 18. I'm gonna divide by 3, and that's gonna give me 6. So when x is 0, y is 6. Then I'm gonna replace y with 0 now. So when I plug it in 0 for y, so this will be 0 now. 3 times 0, 0. So I'm gonna get 3x equals 18. And again, I'm gonna solve it. I'm gonna divide by 3. So that's gonna give me x is equal 6. So my first point is gonna be 0, 6. And my second point is gonna be 6, 0. So these are the 2 points I need to graph. And then I'm gonna do the same for the second line, for the second equation. And the second equation, I'm gonna pick again, I'm gonna find x-intercept and y-intercept. 0 for x, 0 for y. So first one, I replace x with 0. 4 times 0 is 0. So I'm gonna get negative y equals 4. This is negative 1, so I'm gonna divide by negative 1. And y is gonna be negative 4. So that's my first point, 0, negative 4, okay? And then after that, I'm gonna replace y with 0 now. So this is 0, so I'm gonna get 4x equals 4, solve it, and it's gonna be 1. X is gonna be 1, okay? So that's easier to graph it when you pick x-intercept and y-intercept. And then after that, we're gonna graph it. So I'm gonna use my, hold on, I have 0 to 6, negative 4 to 6. So I'm gonna try to graph it more precise. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, so I'm gonna graph the blue line first, the second one. So I have 0, negative 4. This is the point, and 1, 0. And this is my straight line. And then I'm gonna graph the first equation, which is this here, 0, 6, and 6, 0. Oops, I need 6. 3, 4, 5, 6. Okay. So when I connect those two lines, I'm gonna find my solution. So where's my solution? Looks like 2 and 1, 2, 3, 4, right? 2 and 4. But because I'm not graphing precise, I want to double check with my graphing calculator. So 3x plus 3y equals 18. I'm going to just change that here. And you can just enter it the way it is. 3x plus 3y equals 18. That's my first one. And the second one was 4x minus y equals 4. 2 and 4, yeah. That's what we get, right? So the solution is 2 and 4. So see, if you graph a little more precise, you're going to see exactly where the two lines cross each other. And wherever the two lines cross each other, that's where you have your solution. Now, probably you think that sometimes the two lines can be parallel. So these are the three cases you have technically. If they cross in one point, that's your solution. If they're parallel, which means they never cross each other, that means the system have no solution. So this is the case. If you have two parallel lines, they never cross each other. So there is no solution. The system have no solution. And if they cross each other in one point, that's your solution. And the point is x comma y. So there are two number solutions, number for x, number for y. And also you have another case when you have the same line, they're on top of each other. So in this case, you have every point from the line, it's a solution, right? So you have infinite number solutions. And in this case, you have set of solution. And I'm going to show you how to write it. Okay? So let's go ahead and do, let's go ahead and do number 5 or 6, pick one.
6.
Okay, let's do 6. So for number 6, we're gonna start with the first equation. So solving the first equation, I'm gonna see if it's in standard form, the x-intercept and the y-intercept, it's easy to use. So I'm gonna replace x with 0. So when x is 0, 6 times 0 is 0. So I'm gonna get 3y equals 39. I'm gonna divide 39 by 3, right? It's gonna be 13. Everybody see that? So 0, 13 is gonna be my first point. Okay, then after that, I'm gonna pick 0 for y. So when I replace y with 0, 3 times 0 is 0. So now I have to divide both sides by 6 to get x. So what is 39 divided by 6? That's 6.5, right?
Would you keep it as a fraction, or would you do it as a decimal?
Yes, thank you for asking that. Yes, so when you have to graph, decimal is better. Okay, so that's the coordinates for the first graph, for the first point, for the first straight line to graph. Now let's go ahead and do the second one. So for the second one, I'm going to pick again 0 for x and 0 for y. So when I replace x with 0, this is 0. And I'm going to divide both sides by 4. So what is 46 divided by 4 is 11.5. And then I'm going to do 0 for y. So I'm going to delete this. Okay, so y is 0 now. So I'm going to divide by 8. So what is 46?
5.75.
Thank you, 5.75. So these are the 2 points I'm going to use. Okay, and then let's start graphing. So we're going to have the x-axis, the y-axis, and we need to go to we have all the way to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the x is going to 12. 1, 2, 3. Okay, so let's go ahead and start the blue line first. The 0 and 13. So that was 10. 13 is right here. 0, 13, and then 6.5. So you have 6.5 in the middle. And then you're going to connect it with a straight line as straight as possible. And then we're going to grab the second line, which has coordinates 0 and 11.5. So it's over here. And then 5.75. So you have okay. And where they cross. Okay, let's check it here because it kind of looks like they're parallel, but let's see. So we have 6x plus 3y equals 39. So that's the first one. And then the second one is 8 plus 4 equals 46. Yep, they're absolutely parallel. You see that? They're parallel line. They never cross each other. Look at that. Okay, so these are two parallel lines. They never cross each other. Okay, and we're gonna see how algebraically that looks like. So here they're parallel lines. So if they have parallel line, what you're gonna put? The answer is what?
No
No
solution.
solution.
No solution. So we have no solution here. Okay, that's it. Okay, so now this is pretty much how you graph. Any questions on graphing? Okay, so I'm gonna stop here. And the next video is gonna be about algebraically solving a system of equations.